Hey guys, this is group L1G4, and today we're going to be presenting our gesture glove controlled wheelchair. Members of this group are myself, Ernesto Alaman, Mohammed Jamal, and Mark Londi, and we'll each be covering our own nodes that we worked on for this project. Our TA is Victoria Agila, and this is obviously SYSC 310. Our motivation for this project was mainly to help people in manual wheelchairs reduce the physical effort that they have to put into actually pushing the chair, banging their hands, any risky turns that they have to make, going uphill, tight spaces, anything like that. They can just quickly put on this glove, and using the system we've designed, they can control the wheelchair simply by moving their hand up, down, and sideways. This also means that it's cost efficient since they don't have to buy an actual electric wheelchair, which is more costly than the manual course. Mark Lundy will talk about the design overview in a second, since he's the one that actually designed it. So we just skip to the communication protocols. I worked on the Raspberry Pi, as well as the Arduino Pro Mini alongside Mark. The way the Arduino Pro Mini communicates is it actually sends values from the gyroscope based on the X and Y axes to the Pi, and the Pi uses those to move the servo motors accordingly, forwards, backwards, and to the sides. Mohammed Jamal covered the mobile app and the Firebase database, so he will be explaining that as well. Okay. So this is the actual wheelchair model. It's a car right now, but the system is meant to be placed on a wheelchair so that it does all the above mentioned functions. To show the hardware, for the parts that I worked on specifically the wheelchair itself. So these wheels are connected to two servo motors on the back, which have constant rotation, which means that they go the full 360 degrees. So all we have to control on them is the speed and direction in which they go in, instead of just an angle. We also have this camera, which is kind of like a rear view camera for the car. It's the Pi camera, and it works alongside this ultrasonic sensor, which detects the proximity of objects. And when an object gets close enough to the car while it's backing up, the camera will actually take a photo, and you can see that in the app to know what's behind you, so that you're aware of your surroundings and not have to turn if it's nothing serious. Alongside that, we have two buttons. These were just used to test that the servo motors were working correctly, but the servo motors actually work alongside the gesture glove, as I said, to move forwards and backwards based on what the user wants to do. And yeah, that is the hardware for the car that I worked on. Mark will show the rest of it.
My section of the design is from the smartphone between the Raspberry Pi through Bluetooth and through the internet to our Firebase. We no longer require GraphQL, so we can remove this. This is an old design. And that is the design portion. And they communicate from the mobile app to the Firebase database through this, which is our string JSON. And this is supposed to say climate, is how the data gets transferred from the app. The app transmits the Bluetooth data and forms into a JSON string like this, and then sends it to our Firebase database. And from our Pi to the app, it's sent in bytes, an array of bytes, and each byte contains something similar to this or possibly like this, depends on what the Pi forms it as. It could be either of the two, and that's how it gets transmitted from the Pi to the app, and then from the app to the Firebase. Now, I feel like what I learned from what I wanted to do would be to reduce the storage capacity of the app. Currently takes 164 megabytes. That might seem like a lot, not that much, but other apps could take up much less, 20 megabytes, maybe 30 megabytes, which is a significant decrease. And some people don't have the luxury of having a lot of storage. It would have been nice to have that in mind. I also would have liked to increase the performance so that the camera feed could update, and rather than every second, it could update every millisecond to give a constant, direct, immediate feed so that they can recourse and make adjustments to the path of the wheelchair instantaneously rather than with a slight delay. And I felt like I learned a lot about front end and back end design with handling the Bluetooth for the back end and creating widgets and like buttons and pages for the front end. I learned about how to design apps as well as how to integrate them so that they're using APIs so that you can go between different platforms. And it was quite a handful learning Bluetooth, but I'm very glad. Hello, this is a GUI for our wheelchair gesture glove app. Now, this is our start page. This is where the user first starts off when they open up the app. They are greeted with our enable Wi-Fi and enable Bluetooth switches. Now, these switches over here will be off if the Wi-Fi and the Bluetooth are not enabled. Now, see here, my Wi-Fi is enabled since this is blue, and our Bluetooth is enabled and already connected to our Raspberry Pi. Thus, you saw that this was automatically in on position. Once both of these two are on, we can then continue to our main page. And now on our main page, this is our data screen shown at the bottom over here, sensor data. In this screen, the data sent from the Bluetooth from the Pi sensors are transferred through Bluetooth to the app, and they are shown here for the user to read as they're going along about their day. And here, these readings update automatically every second, I believe. And every second that the app receives these, the Firebase database through HTTP is also being sent these values and is constantly updating their tables so that the Firebase and the app are continuously in sync with what they're displaying. And in our other screen is the camera feed. And in this camera feed is what's going to display the footage from the Pi's camera that will also be sent through Bluetooth so that if any object or obstacle is perceived from the proximity sensors, then pretending the person's on the sensor data, it'll automatically switch the camera feed and show them the captured footage that will populate this screen. Currently, there is no footage being displayed and sent from the Pi, so we are receiving this circle instead. And once the footage is being received by the Pi, by the app, this area will be displaying the footage. And obviously, we can switch between the two. Perhaps the person wants to back up and they prefer to look. They can then press this and look behind them.
So for the gesture glove, we have three main hardware components. The core of the gesture glove is an Arduino Pro Mini at 5 volts and 16 megahertz. Connected to it, we have an MPU 6050 accelerometer and gyroscope, and it can also sense temperature, but we aren't using that feature. And we also have an NRF24 LO1 transceiver, which is what we use to communicate to the Pi from the gesture glove. In order to complete the communication from the MPU to the Arduino, we also have two level shifters, about 4.7 kilo ohms, we use so it can communicate through I2C communication with the Arduino. On this end, on the actual car, we have the transceiver on the car so it can receive that information and power the servos accordingly with the sensor data from the MPU 6050. So for the design overview of our project, we basically have three main nodes. We have the Arduino Pro Mini, which is the core of the gesture glove. Connected to it is a MPU 6050 gyroscope and accelerometer, and a transceiver to send the sensor data to the Raspberry Pi, which is the core of the wheelchair and controls everything there. It itself has a transceiver as well, which receives the data from the Arduino Pro Mini, and through some couple scripts, it will control the servo motors accordingly. Hooked up to the Raspberry Pi, there's also a camera with a proximity sensor, an ultrasonic sensor for obstacle detection. There's also a sense hat for further sensors. The third main node of the project is the application, the GUI for the user. It's a smartphone application which gives the user access to any of the sensor data and travel information from the wheelchair itself, as well as the access to the camera and the sensor. And all the information from the smartphone app is stored on a Firebase database. For the future work for this project, We definitely need a proper battery pack for the Raspberry Pi. There is a juice hat that you can buy for the Raspberry Pi, but it costs around like $200. Right now, we're just using a battery pack consisting of a few AA batteries. Also, we did experience a lot of hardware issues with some of the sensors, including the NRF24L1 transceiver, as well as the MPU 6050 currently, which is stopping us from sending sensor data from the MPU to the Raspberry Pi right now, which prevents us from actually logging any information from the user's hand movements. It has something to do with the I2C communication, so we're still troubleshooting there. We definitely learned a lot about the engineering design process in this project and just how complex it can be, mainly just the troubleshooting and solving problem that can be involved in a project of this scale. Like I said, we've experienced some hardware issues and we're still working through them, but it's definitely quite an experience. And we mainly learned a lot about troubleshooting and just how complex it can be, and the right process, taking the right steps, going through it, and making sure we cover all ground to make sure that everything works properly. But it's been all around a good experience, but definitely a good troubleshooting experience and learning some new skills there.